if you want to look at yours face to face. All right, so I'm recording now.
Okay.
And what I'm doing is this. I'm sitting back here talking about, first thing is talking about the notation. So this is like the mimic for item number 1. Different pizza shop. Wow, slow down, Barnes. Different pizza shops in Cheney and in Westchester are randomly selected, right? And their ratings and prices were obtained from their websites. Using technology, with X representing the ratings and Y representing price, we find that the regression equation has a slope of 150 and a y-intercept of negative 263. What is the equation of the regression line, right? And then the other is, what does y hat represent? All right, Amber, excellent.
I'm sorry, I'm late. I had to clean up the kitchen. I'm sorry.
Oh, no problem. I'm glad you're here. I'm definitely glad you're here. Essentially what we went over is just the fact that we're not going to be going over the actual homework problems, but rather the essence of statistics problems, which are pretty much the same thing with different numbers and different contexts shared on them. So I read this problem. I'm not going to read this just so Wisdom isn't like bored out her mind, right? But I will focus on the information that I think is kind of relevant.
Okay.
Our question is, what is the equation of the regression line, right? And then the next one is, what does the symbol y hat represent, right? Now, on the surface of this, you might sit back and say, what's the equation of the regression line? The next slide, which is here to help y'all, right, is showing the class and showing you guys this. This is the equation. This is the equation for the regression line, right? Y hat equals B sub O, and then B sub 1x. That's the equation that we're looking for, right? But that's not really what this problem is solving for, really asking for. It's asking for us to plug in the appropriate numbers, right, into it. So to a certain extent, you have to know what B sub O is, right? And you have to know what B sub 1 is. And just to kind of fill this in, y'all let me know if I'm wrong, but I think I'm right. B sub O, that is the y-intercept. Y-I-N-T is what I'm going to put. And B sub 1 is the slope. Right? So when you're going over this problem, whoever goes over this problem, you just want to sit back and let them know what B sub 1 is, B sub 0 is, right? And since we know that B sub 0 is the y-intercept, then we should rewrite this equation like this: negative 263 plus B sub 1 is the slope, so that's 150x. And then y hat, right? This is if we were to use this equation, this is the equation that we would use to kind of predict that. The next is, what does the symbol mean? And this is just kind of known, I kind of went over this a little bit in class, right? But the y hat over top of it is an estimate, right? So that means we're estimating what y is, or we're predicting. So y hat, which is this right here, I should just be drawing it a different way, that represents our prediction. We got some data, we lined it up, and based off the data, we're going to predict the different price, or actually, I don't even know which one is which, right? So hold on. Y is the ratings price, right? So if I look at the ratings from the website, I'll be able to predict the price of the pizza at these two places, at either Cheney University and Westchester, which is kind of the thing. But again, that's all number 1 is asking. It's asking, what is the equation of the regression line? One, I think, to let the students know, remind them of the regression equation. That's in the textbook. They should know this. But then plugging it in with the information that's kind of listed, that's the hardest thing, and it doesn't take that long. It's just kind of right here. The hardest thing is trying to remember this right here. B of O equals the intercept, and B sub 1 equals the slope. All right, any questions on any of that?
I do have a question, Dr. Barnes.
Okay, go right ahead, go ahead.
So this equation, I don't know, I read this in a textbook and I heard you say it. It's basically the same as y equals mx plus b, but is it like the b1x is the mx and then the b0 is plus b?
Yes, so it's switched. You're absolutely,
Okay.
and that's the only way to kind of make it. So if we were to sit back and make it perfectly, y equals mx plus b, it would be y equals b plus mx, right? Now, if you add certain things, there's no difference between mx plus b and that. Like it's the same thing because we're adding it, right? But yeah, it is a little different just because of the order and the focus. And the only reason why it's different is because, again, I think you notice, I don't want to scare you right now, but in the next chapter, which is multiple regression, we'll be able to add more on. And it doesn't really make sense to be mx plus b if we were to add on and then have like what, nx? And then what's after n? Ox, you know what I mean? Like that would look kind of weird. So they switched it just so that they can kind of be added on to each other in a way that kind of makes sense.
Okay, thank you. I think that's why I was getting confused with these problems. Thank you for clarifying that.
Yeah, no problem. And again, you all let me know, because I know I can have a habit of kind of going on. I don't want to go into another conversation that's getting you lost. So I'm trying to do that. I'm doing it a lot better, I think, in terms of stats. Make sure I'm not rambling. But yeah, you let me know. Be like, Dr. Barnes, pump the brakes. Like you losing me now. Okay, so that's question number one. Question number two, how is the equation y equals, right? B sub x, capital B sub x, wow, I'm sorry. Capital B sub O plus capital B sub 1, x of 1, right? How is this different from the equation provided for exercise 1? Right, now to help you guys answer this, I have this next slide. So it's showing you, this is one from equation 1. That is what we had from the first problem. People just saw it a second ago, right? And then what we're doing down here, again, if you guys are comfortable with it, you can sit back and draw the y, right? B sub O plus B sub 1, x1. So you're comparing this equation to that one. What's the difference between those two, right? And the answer is really right here. Now, I have this because this is from the reading. I don't know if I put the page number here. I don't know what page this is on, but this is from the requirement section, right? And in the requirements, I know it's a graph, many of us skip over it, but it goes into talk about the notations. Like it even says notation right here, the notations, right? B's, lowercase b sub 0, b sub 1, that's what we use for a sample statistic. So when we look at this right here, we know that this is not based off the entire population. This is based off of a sample. However, if we're looking at capital B sub 0 and capital B sub 1, we would know that's a population parameter, which means like it's in a situation in which we were able to get every student at Cheyney and try to predict their GPA from something else. We were able to get every kid at a school, right? And predict their, I don't know, the number of tardiness from how far they live away from school or something, right? We would use capital B if we were able to, if we did our data on the entire population. That is really all number 2 is. It's really about, in my mind, just making sure that you've read it before and just making sure that you kind of apply it.
Mm-hmm.
On this?
What'd you say, Dr. Barnes?
Oh, no, I thought I spoke over you, Wisdom. I didn't know if you had.
Oh, no, I understood. I was just listening. I was just saying.
Okay. And I like that. I like it. Don't worry about that. All right. Now let's move on to question number 5. I think we're skipping 3. I didn't think 3 gave us anything. And I think in due time, as complex as we get, it's probably going to be a good deal that we skip number 3. Right. But you guys just go over what we're doing in class. Now, as I always say, the most important thing is to make sure that they have read these instructions. Right. There's a lot of people who try to do these problems in the class and they don't even know what's being asked. And sometimes this will say, write the hypothesis, do this, do that, give the T critical. And if people haven't read this, then they don't give it to me and they lose points on it, right? So in exercises 5 through 8, let the predictor variable be the first variable given, right? So that's saying when you read this, the first one given is X, right? Use the given data to find the regression equation and the best predicted value of the response variable. Use the given data to find the regression equation and the best predicted value of the response variable. Now, this right here is kind of a catch because if you guys remember, they talk about linear correlation is only useful when you have a linear correlation, like the data has to look like it's linear, right? Now, what's in the textbook, and I'll be honest, I think the first time I did this, I didn't see it either, was it says this: if you have a significant multiple regression, then you use this equation. This equation right here, then we use it. However, it also goes on to say that if we don't have a significant equation, right, then we don't use this regression equation. We just use Y bar. And that is what's hidden in all the other products that's done here. And it doesn't really say that. You know, it does say it right here, use the given data to find the regression equation and the best predicted value, but it's not really reiterating to people that, look, you have to find out whether this is a good model. If it's a good model, then you use a regression equation. If it's a bad model, then you use Y bar. And that right there is some understanding that is kind of, I think, overlooked when people are doing the homework assignment. And you know what? I actually feel like when I say this right here, I need to include some of this content earlier in our presentation. What I have later, oh no, wow, I'm sorry. It is here. I thought it was much, much later in the presentation. So I'm giving you that kind of if or process that we have, right? Both of these slides look the same. I'm gonna delete this. We don't need the second one, right? This is going back to the textbook. And this is what students should have read before, right? This right here is talking about how to make predictions, right? Regression equations are often useful for predicting, blah, blah, blah. When making predictions, we should consider the following, right? So let me sit back and see what this says to us. If it's a bad model, if the regression equation does not appear to be useful, to make predictions, don't use the regression equation for making predictions. For bad models, the best predicted value of a variable is simply its mean, right? Now, for some people, we might have to remind them that the mean, right, is Y bar, because Y is the variable that we're trying to predict, right? So when they say the mean of that variable, we're talking about Y bar, because we're not trying to predict X, we know X, right? So that's what needs to be kind of relayed to the class right there. It's what they should have read. I might add a page number on it just to let people know that when you're reading it, they can really see that, look, if you read like you're supposed to, you should have already went over this, right? The other thing that's to be shared on this page is, what do you do with a good model? Then you use the regression equation for predictions only if the graph of the regression line conforms to the regression line. Oh my goodness. Use the regression equation for predictions only if the graph of the regression line on a scatter plot confirms that the regression line fits the points reasonably well. Now, you know what? This is a little misleading, and you guys let me know if you can remember this. The reason why is because this is almost saying that we look at a scatter plot, right? But there's a couple of other ways we can find out whether it's a good model. One is looking at the p-value, right? Now, if I sit back and tell you, if the p-value is less than what will we sit back and say it's a good model?
One?
0 point,
I'm sorry.
is it 0.05?
0.05. Yep. So this is saying you can look at the scatter plot, which is true, right? But you also can look at the p-value and see that it's less than 0.05. If it's less than 0.05, it's significant, and then we would say it's a good model, right? That's one approach. I'm going to try to add this in here if I remember, so that y'all don't have to come up with it. But if you read it, you'll be able to sit back and know to share that with the group. The other thing is this. You guys remember this. You can go in the back of the book. I think it's table A6, right? When you go on table A6, it will give you the critical value for a correlation. So if we knew that n equals, if we knew that n equals 5, we could go in the back of the book, right? And we can find out what the critical value is for correlation for n equals 5, right? So this would be +1 right here. This would be our -1 right here. And then we'd be able to find that critical value. And just like we always do before, this is a different way, right? We will be able to sit back and say, all right, so this is our critical region. When we calculate the value of our regression, we need to find out whether this regression is either in the area that's not critical. This would be a bad model, so we would use Y bar, right? But if we find that it is within this region right here, then it's a good model. And then we would use the equation that we have right here. So I will add another line. I don't think that this point right here about the number line, I'll put it like this. If I want to talk about the number line, I will jump in and share this number line issue, right? So whoever's doing this problem, I'll jump in and do that. But I will add another paragraph that looks like this, that's saying that you can determine whether it's a good model or a bad model by seeing if the p-value is less than 0.5, which is what you guys know. So that'll be up here. So if you highlight, you know, this portion, that portion, and then what I add onto it, everybody who's watching you will be able to get it. Now, Wisdom, I think I was cutting you off. You okay?
No, I was just saying I was understanding.
Okay, all right.
Thank you.
Any questions on that? Now this is half of it, right? So again, this right here, you guys are really going to be drilling in a point to the class. How do you find out whether it's a good model or a bad model? It's this writing right here and then the paragraph that I'll add. All right. Next, there's also a chart. This chart is saying almost the same thing. Is the regression model a good model? Right? You can ask the question, the regression line graphed in the scatter plot shows that the line fits well. R indicates that there's a linear correlation. The prediction is not much beyond the scope of the available. I might add one more about the p-value is less than 0.05 right here, right? And that'll just be an add-on that I do. I think that's something that's really important. I don't know why they're saying it. They're not saying it right here. So I'll tweak this graph to make it like a Dr. Barnes graph, right? But if you read this, it'll be there. Now, if it is a good model, the regression equation is good. So we use this. And then if it's not a good model, then we use Y bar, which is pretty much what we were saying here. It's just a graphic way of doing it. So literally this is, again, this is almost bragging in my mind, right? This is showing them, look, if you really read and you really understood this stuff, it's already telling you these things. But I get it. I don't want to come to people like they're not reading. I think many times it's hard to comprehend what this author is trying to say. So again, don't be like, y'all didn't read. I would never say that. But it is about making sure that like you read this, right? This is what it meant, right? So that's how I would craft it if you even want to go that route, right? So both of these graphs are really drilling the point. We still haven't done anything. We're just showing people that like, look, this is how you do the problem, right? Or what we've read before to do the problem. Now, this is the page in which we will actually solve the problem. And what I tell you, what I would suggest a person who does this is to look at it. With all this information that we have right here, there's two things that we need, right? We can look at this. And when we look at that information that's highlighted, that will let us know whether we should use this to predict or whether we should use that to predict. And essentially, I mean, we could do it, but I think it's kind of right there. 0.063, right? And then 0.05. Is that greater than or is that less than 0.5?
That's greater than?
It's greater than, right? So if it's greater than, is it a good model or is it a bad model?
Bad model.
There you go. So since it's a bad model, that means we're going to use this one right here. Now, had it been the other way around or it was a different number, we would have used this to predict it. Right? But and what we would essentially would have done if we would have put 8.8, that does not come out right, minus 0.345, and x according to this equals 7, we would do that. And whatever that equals, that would be how we would predict what our y would equal. That's how we would predict y hat if it were a good model. But since it's not a good model, we're just going to go with y bar. Someone's like, why bother? If it's a bad model. I like that. I'm going to use that in the future. Why bother? Dr. Barnes, I'm getting corny. I'm sorry. Any questions on that, guys?
No, pretty straightforward.
Yeah, 5, it's a lot of slides. It's a lot of babying through what's going on, but I think it will make sure that they understand it. And then when they do the one for homework, which is different, I think in some kind of way, again, we didn't do the work for them. We showed them how to do it. So yeah, I'm really excited about this.
Dr. Burns, I have a quick question.
All right, go ahead.
So for these types of questions, basically, like, we're just determining, I guess I have difficulty reading the instructions for some reason. But for this question, it's not really a lot of work we have to do. It's more so determining if it's a good model or bad model.
Yep, and that's
Okay.
all. And you know what? And I'll tell you, I trust me, I get frustrated too with this author. I wish I had time to write a stats textbook, but I don't. I think that's what he's trying to say here, but it isn't clear. Use the given data to find the regression equation and the best predicted value of the response variable. You know what? And I'll tell you, once you know how to do it, you read this and it's probably easier to digest, be like, oh, but when this is the instructions to do it, yeah, it isn't clear. So I definitely understand where you're coming from, Amber. I wish I could find a better way of making it clear, and I don't really know. I think math is one of those things that it's the beauty of hindsight. My kid right now, my oldest son, he loves to scuff at word problems, right? He's just like, I don't care. I can do the math. I just don't want to do the word problems, right? But I think a lot of us have that approach. And I think that's the reason why we get into a little bit of trouble. Like, we're using words, right, to have us solve a problem. And we would much rather just put some numbers in and just do it. All right, so that's how 5 will be done. Let's move on to number 13. Now, pay attention because there's 2 ways to do 13. Amber, you did one way, right? And I think another way that you also could do it is consistent of what we did in the past. And actually, I think in the future, I think I will have them do it. I think the way you did it the way I had in the homework. You did it the right way, the easier way, right? But most people in the class, I think they're cheating and stuff like that. But most of the people in the class was using the data chart. And honestly, I think that it probably will be easier for them to do that as opposed to introducing something new. But what we're going to do right here is break this up, right? I think it'd be great if like one of you could do one approach, the other could do the other approach, just so it's kind of like a tag team. But this is the problem. Let's read the instructions first. Regression and predictions, right? So for exercises 13 through 28, use the same data sets as exercises 13 through 52. That's probably wrong, but it doesn't matter, right? In each case, find the regression equation, letting the first variable be the predictor variable. So the first one you read should be X, right? Find the indicated predicted value by following the prediction procedure summarized in figure 10.5. And you guys already did that. That's like saying if it's a good model or if it's a bad model, which one do you use, right? All right, so that's what we need to do for that. All right, so let's look at the first approach. Now, the first approach is kind of what I wanted people to do, right? Because I gave you something like this. You guys might remember this in the back of the book for the on the back of the homework. right? This right here was an easy way to do it. I gave you all the information you needed, right? Because in order to find the slope, one way to find the slope is to do R, which is right here, over the standard deviation of Y, which is right here, over the standard deviation of X, which is right here. That's simple, right? The other is to do the y-intercept, right? The y-intercept is to take y bar, and y bar is right here. Subtract that by x bar, right? Or actually, no, b sub 1. And this is why it's kind of weird. So you got to solve b sub 1 first, right? And then plug it into that equation, right? Let me do this the right way. So I think this would be right by doing b sub 1. And then you find y bar, which is right there, and then x bar, which is right there. So that's pretty much like the easiest way. That's what I wanted people to do. But yeah, people didn't do that in class. And it might even be my fault, because I don't know if I went over it this way in class, right? But one way to do it is to take R. R, according to this, is negative 0.434 over 5.7 divided by 0.598. That's b sub 1. I don't know how I got congested real quick. All right, so 5.7 divided by 0.598 times 0.434 negative, though. For my math, it looks like it equals negative 4.137. Now let's do the next one, right? So it's b sub 0, right? So y bar equals 5.7 minus 4.137 times x bar, which is 0.598. Let's do the math for that. That's b sub 0. All right, so I got to do this right. This right here is a negative 4.4. So this right here is a all right, so this right here, getting the value of negative 2.47, I run it to 4. So 5.7 minus that, so you plus both of these. $5.7 minus 2.474 gives me a value of 8.174. Now, you guys able to follow me with that math?
Yes.
Okay.
Yeah.
And from this, right, we should have a y hat. We want to use a regression equation. 8.174, because we put b sub 0 first, minus negative 4.137. And then the x sub 1. That would be our regression equation from this approach. Now, I almost wish I could take a picture of this or write it down. I'm going to write it down in chat. just to make sure we can double check and make sure we get our numbers right. All right, 8.174 minus negative 4.137x. Okay, so let's clear this.
Dr. Barnes,
Mhm.
so did I do it correctly? I think I went a step too far and I put like 79.5 for the X value. I don't know. I tend to go too far in the
No. You know what? You did do something a little bit too far, but you know what? I don't think that's the reason why you got an item wrong on it. If you go back and look at your problem, I think for the actual homework, because I just graded yours today, I think you should have used X as 79.5, and I think you use X as 79.1, or maybe vice versa, right? So
Okay.
I think that's what made me say that you were a little bit off. And again, I just graded. I didn't remember what you did wrong, but I think you did something very slight like that. And I'll tell you, one or two items wrong like that, it might not even be worth you going back and doing it. But you know you can if you want to. You can go back and resubmit it and get like a portion of those points back if you want.
Okay, I'm sorry about that. Thank you.
Oh no, don't you apologize. This is what this is. Honestly, this is what I'm really trying to create in this course. It needs to be not just trying it and being done. It needs to be that persistence. So I like how I think in the future, unfortunately, I will be doing this class 3 days a week, and that Monday will be taught like you guys are doing it right now to each other. But yeah, don't apologize for that at all. All right, so that's approach one, right? Now, the other approach on how to do this problem is kind of like the old school way, right? And this is kind of by hand. Now, for this, I would like for y'all to play with them a little bit, right? Now, what I mean by play with them a little bit is to have people in the class kind of do some of these problems, right? To get X squared, ask for some volunteers about what's 0.52 times 0.52, what's that value squared, right? You can either go to annotation and type the answer in, right? Or you can use the drawing and kind of write that number in. Just use a different, better color than that, right? Now, here's the thing. I would start off by doing like 1, 2, 3, depending on how fast people contribute, right? You can do the next row, right? Of this, that, and this, but we got to pay attention to time, right? Because this is one of those longer ones. And the reason why I said play with them is because you know, I know, and they will soon know that on the next slide, I actually went ahead and answered all these problems for them. Right. But again, I just want to make sure that everybody in the class has an opportunity to understand that we do unfortunately have people who don't know how to get this value from this equation. Like they don't know how to square X times X. So as for a couple of volunteers, I think depending on the issue, I'm not having y'all do my job, right? Sometimes it's like pins and needles trying to get people to contribute. So if people are bringing in these numbers really fast, then you can do 2 rows. If it's taken a long time, just do 1 row, right? The other issue that I would focus on is that down here, these are not values. At the very bottom, these are the sums. So this is what happens when you add all those values up. You add all these values up, all these values up, et cetera, et cetera, et cetera. That's what the summation means. That's what the sum of X means. This would be the sum of Y. This would be the sum of X squared. And again, I know that you guys know this, but there are people, it's worth going over this just because there are people who don't get it. And this is the sum of X, Y because of what's up top. All right. Any questions there?
Nope.
All right. So moving on to the next slide, right? In order to solve this, the second approach, we need to use this equation. And this equation is written up here. I would suggest the individual does it one at a time. I mean, unless you're good at writing. I'm good at it. I've been able to do this for a little bit of time. But my suggestion would be this. You look at n, how many n? You can talk them through that. It should be, wait a minute. Wow, I am bugging, guys. I am so sorry. I thought I counted 5 down here and then 6 over there. Time to retire, Barnes. Time to retire. All right. Best thing to do is to make sure you have the n equals 6. You know, they know what n is. You can count the 1, 2, 3, 6. If you want to go over how these are supposed to be paired, you can. I think they should get it. But again, it's your comfort. I'm here to help you, right? So that we have n equals 6. Then you're looking at what's on the screen right now, just kind of recreate it by plugging those numbers in, right? So n equals 6. The sum of x, y is right here. So times 17.511 minus sum of x, that's 3.5. So 3.5 times the sum of y is 34.2. All right, and then we have 6, which is n again. Sum of x squared is right here, 2.628 minus the sum of x squared, and that's probably the hardest one. Right? Sum of x is 3.5, and then we're going to square it, right? Now, let me ask you this, just to make sure that we can do this. Have you guys ever used the annotation feature on in Zoom before?
No, no, not really, no.
Okay, now that's what I want you to do, right? Since you mentioned that you haven't done it first. Look on your screen, right? And there should be a little tab bar that lets you see kind of the functions. Go over and what you should see on that little bar where you could do like new share and all that kind of stuff. You might see an option that says annotate. Do you see that? Okay.
No, I don't see it.
Ooh, I honestly, I think you're doing it. I saw it pop up on the screen. Let me get out of annotate so I'm not competing with you. Did you do that?
Yeah, okay, so it's the little pencil in the circle?
Yep. The little
Oh.
pencil and it says annotate.
Okay.
All right, so you can do 1 or 2 things, right? You can either, and again, y'all want to tag team and help each other, right? So if Wisdom, imagine if you're doing this slide, right? It might be beneficial if you're not getting anybody from the classroom to help you, Wisdom, that Amber, you can do this math for them, right? But what I would like to see you do, Wisdom, and I want to see how your handwriting is and how it gets a little bit better, right? Is do all of these in chunks, right? And this is how you help students see the problem about doing it in chunks. By don't just go all the point, but say that you had to multiply 6 times this, right? And then write the answer above it right here, right?
Mhm.
And it's a minus, and then 3.5 times 342, write that answer right here.
Mm-hmm.
Do 6 times this number and write it below, and then you'll have a minus, and then 3.5 squared is that. So if you can go ahead and write on those problems, we'll do it. Amber, if you're with,
Okay.
I'd love for you to do the math for her in your calculator or whatever. You can give her the answers, but if not, you let me know and I can do it.
Okay, I can do it.
It takes a little while. Yeah, look at that.
I was testing it out.
No problem, no problem. And for me, guys, I'm going to tell you, once you do this step, I wouldn't go any further doing the math unless we have time, right? But I think a lot of people in the classroom know how to do number crunching, right? They know how to do the number crunching. What they don't know how to do is like how to get the rationale and the reasoning. So I would say after showing them these baby steps right here of putting it above where they belong in the way that I'm kind of suggesting, if we're running out of time, we can just be like, all right, that's it. We'll see you later. But if we have more time, I can go through, I can jump in and help you. But for doing this for B sub 1, right? And then doing it for
Mhm.
2, which is we haven't even done yet, that'll be enough, I believe. That will definitely be enough. All right, so can you write on the board? It takes a little get used to. I want you to practice a little bit.
Okay. What did she already gave me the answer for 6 times 17.5. Oh, okay.
I'm sorry.
No, you're fine.
My calculator is kind of being weird. I got 105.066.
Okay. That looks so bad.
Don't worry about it. Let me tell you, if you keep doing this, it's going to get better. It's just a habit.
I feel like my fingers. I don't know.
Are you on a phone or are you on a laptop?
On the iPad.
Yeah.
She said 105. Ew, this is
0.066.
terrible. This is terrible.
First of all, your 5 look just like my 5, don't it, Amber? Like, don't be so critical.
I'm about to say it looks actually really good.
Yep. All right, and then the next one is 3.5 times 342. And again, if you want to be like kind of a teacher, you can sit back and actually no, I did it wrong. 35 times 34.2.
Oh, is it?
No, I did that right.
Is it 3.5 times 34.2? I'm sorry.
Yes, yes, it is.
Okay. 119.7.
Oh, geez.
The one in front of the other one.
Wait, what did you say, Dr. Barnes?
Yeah, put a 1 in front of the first one.
1 in front of.
Yeah, like you see where you got your 19, put another 1 in front of that. And it's
Right there.
Sorry, 119.
Okay.
And then put a
0.7.
7 after that. Yep. All right, and then down bottom.
The next one is 15.768.
Ew, no, I gotta redo that.
No, I am laughing at that one. I ain't gonna lie.
Oh, snap.
Don't laugh, Amber. You next.
Oh my gosh, I don't know how to draw 8 like you, Dr. Barnes. I haven't drawn one like that in forever.
Don't worry.
Does that look okay or?
Yes, it does. And you know what? Here's the issue. Since you're saying it verbally, and if they're attending to you in real time, they're going to see things that it might not look that way. You're being overly critical on yourself. This looks really good.
Mm-hmm.
Thanks.
All right, and then 3.5 times 3.5 is
12.25.
Yep, 12.25. Look at her go. All right. So, and then here's the issue. You can stop now. We're gonna put this little spotlight on you, Amber. If you can, like, again, we're not gonna go through this. If people want me to jump in and solve the problem, we can. But like I said, I think a lot of people are really good at, if you get this far, being able to crunch the number so we can save a little bit of time. This is what I'm focusing on you for, Amber. If you can do, write out this equation with the appropriate numbers from up here, I think it'll give you enough of that feedback of like how to write. And I'll tell you, you might look weird today, but you'll probably even look better tomorrow.
Okay. I'm sorry. Where do I go for
Okay, no
the
problem.
pencil?
There's usually a toolbar at the bottom of Zoom, and in the middle you'll see that green when it says new share, right? Now, new share. But on that same bar, if you go like over to the right, you'll see like a pencil and it says annotate.
I don't know why. I literally cannot see it. It says participants chat and then share screen, record, and reactions. I don't know if my
All right,
computer is
now
being
what are you
weird.
on? Are you on and let me ask you this, can you see my bar now?
Um, e- I see it's like dots.
Oh,
I see.
okay, so you still can't see it. How about this? I'm going to send you this in screen. Oh, I know how to get there.
Oh, never mind. I see it. I'm sorry. It says annotate
You got it?
under view options.
Okay. Yep.
Okay, I see it now. I'm sorry.
Now,
about
so
that.
hold on though. I just want to make sure. Does yours look different than what you see on the screen?
It's kind of blurry on the screen.
Mine
But
don't like that.
Yeah.
yeah,
I just want to
I
get
don't
an
know.
idea. I think depending on what Zoom you have, it's different ways. So you said it's under screen and then screen options?
It was actually on at the top where it says view options. It says you are viewing Chris Barnes PhD screen, and then it has a thing next to it that says view options, and it's like a down a drop down arrow,
Yes.
and
Okay.
then
All right.
under that it has the annotate.
That's good to know. Like I said, everybody's Zoom is different. My kids have a very funny and different one. It probably does differ depending on what version of the software you have.
I'm sorry, Dr. Barnes. On your screen, it kind of looks blurry for me.
Okay, let me see if this, is that better?
Yes, that's better. Thank you.
Yep.
So just put in the equation. Okay. Oh.
You're doing a good job too.
It's really difficult to like keep a steady hand.
Yeah,
I'm trying to use my mouse, but it's not.
Trust me. If y'all will go back and look at how I am now versus the first when the semester started, yeah, it's crazy. You get better. It's no biggie. What you could have done with that number that you just did is you could have rounded if you wanted to.
Okay.
But you don't have, I'm not saying you have to, but like you could have just rounded.
Okay. So make it like 2.63.
Yep. Mm-hmm.
Okay.
And honestly, if you're nervous or if you're depending on if you want to feel like you want to get in a teaching environment, even if you write it there, right? While you're writing, if you're worried about people focusing on you, you could even ask them, guys, if we wanted to round that one, right? What could we round it to? So while you're still writing right now, you'll have people turn off their mic and share something, and it won't really matter to you. You're keeping it moving. But that's just some ideas to kind of make yourself a little bit more comfortable.
Okay. So I could do the same thing with this one, like just put 17.5.
Yep, if you want to. Yep.
Okay.
Thank you. You got a little fancy 7 with the little line in between.
1, 2, 3, 4, 5, 6.
I'm really thinking about going out and getting a stylist.
No, please don't do that for tomorrow. Please don't do that. Trust me, there is nobody, you should never feel embarrassed, because let me tell you, it's hard to get people to be able to do this in the class. Like y'all are doing well. Don't let anything or anybody in any way make you feel bad. All right, now here's the thing. The only thing I see is with your, ooh, you messed up at the end.
Oh man,
Do you see it?
I don't.
You know what? I think you did this in your homework too. All right, I want to focus on this.
Oh, square. Oh.
Yeah, but not only that, look, you put the sum of x squared, right? The sum of x squared is a 2.63, which is what you rounded. It's sum of x
Yeah, 3 point.
squared.
Okay. Yeah.
Yep, I
I'm
think
sorry.
you did that
Sometimes
in
I
your,
have issues with numbers for some reason. Like I'll mix them up.
you know, I don't know why y'all like doing that. Like you try to make yourself feel bad. This is college level. This is hard. Don't apologize for anything like that. Even if that is true, you don't have to share that as if that's a reason. This is pretty challenging stuff. Here's one thing I'm gonna show y'all just to give y'all a point. Y'all can say it tomorrow if you want to, but I didn't realize that until this year. If you look at this denominator and you look at this denominator, they are exactly the same.
Yeah, I've noticed that.
Yeah, they are exactly the same. And you know, I was just doing some stuff in Excel and just trying to get the answers correctly. And I'm like, oh snap, we can save a lot of time by doing that. Like if you remember what was on the previous page. So yes, this is two ways of solving this item, right? Find the predicted value with X value being the amount. The one thing that I haven't done right here, maybe I need to do this, is this. Kind of like I said before, they don't give you a value of P, but we can go back and look at the table. Let me go see if I can get there real fast. Textbook is not listed. Let's go to vital source. I tell you, man, vital source is making bank. I might put this in there, I might not, but we're solving this problem, but we're not really going all the way to the end like we should. And the reason why I say that is because right here is how we would find out whether it's a good model or not, right? So I might go over this at the very beginning or add this while you guys are there. But N in our problem is 6, right? So, and then we assume it's 0.5. So N equals 6, alpha is 0.5. Our critical value, in order for us to say it's extreme, we get a little number line, and this is +1. This is 0 right in the middle, and this is -1. Our critical line is going to be right here at 0.811 or -0.811. Now, the value that we obtain, I'm pretty sure it's somewhere in the middle, right? And this goes back to what we talked about before. Since it's in the middle, right? Then we use Y bar because it's a bad model. But in the event that we got something lucky and it was like either here in the extreme area or somewhere over here, right? In our critical region, that's extreme. And then we would use Y hat equals, oh my goodness, B sub 0 plus B sub 1 X, right? So I think I will drill that in to kind of help you guys so you guys aren't on your own. I might add a slide in there, but yeah, that's it. That's it, guys. We are, wow, this is actually within an hour, which is actually pretty good. Without me talking, I'm pretty sure y'all could probably get through it. Here's the issue I would like to ask you guys though, and I'll clear all these problems. Annotate, clear all drawings, right? Looking at these problems that we're gonna go over, we have problem 1, and that's, what is that? I'm gonna say EQ for equation. right? We got problem 2, which is notations. I'm going to say note. Right, and it has all these slides. We got problem 5, which is, what would I call that? That's looking at, I'm going to call that p-value, because the main thing is to look at p-value to see if it's a good model or bad model. And this has a number of slides to go through, but just like you guys were saying before, even though it's a lot of slides, it's not a lot of math. You know what I mean? But that is a lot of talking. I'm not sure if y'all want to divide that up together or not. But again, first highlight the reading, highlight the chart, and then highlight, the fact that all we got to focus on is that p-value up there. And then item 13, right? And I'm going to say 13A is the first approach, which is the first one we did, and then 13B, which is the second approach, getting the same answer. Now, based off these things, do you guys have any items that y'all want to break up so that y'all kind of know which ones you want to tackle tomorrow?
I mean, if we're gonna like do every other or just like break the first part and the second part,
Your
I
call.
would do the first part.
You do the first part?
Mhm.
All right, now the only thing I'd say this, now Amber, you gotta make sure you're okay. If you're gonna do, now I would say this, if we're gonna do the first part, I would do it like this. I think you could do 1 and 2, right? Amber could do 5 and 13A.
Mhm.
2 of you do 13B together,
That's
That sounds
fine.
good.
all right? That sound good?
Yeah, and then I mean, like, if she want me to chip in or anything,
Oh
doing
yeah,
like he's
definitely,
doing it.
definitely. I trust me, I think it will benefit you guys a whole lot if you don't view it as, I don't gotta say nothing because it's her time. Like, I don't think either of you are there,
Yeah.
that kind of approach, but it really is good to kind of support each other. And I think if you support the
Mhm.
person, they'll support you.